What the fuck? This time it really rains here. Ah, fuck. No, anyway. Really. Yeah, long time, Mitchell. Hey. Right. Opposite extreme. So I use uphill, then next extreme is a maximum and the opposite extreme is a minimum. Uphill, minimum. Dude, it's defined in extreme chain. Not even a header. What the heck? This is for shit. Yes. Yeah, this is real. It was really raining here, and this is real. Wat is onweer in het in English? Ja, dat is oké. Slash or thingy slash. But duh. Yeah, I'm over 4 months. More than 4 months at the moment, working on this gradient descent thing. Yeah, well, this is not allowed. I think I have to test for that thing as an unfound maximum. Look. Does it work like that or not? Building. Get in right is flat high. And is not allowed to contain the opposite extreme. So returns true if this does not allow the opposite extreme. Forgot how I did that. I think I just stopped working. Nope. I think it's this, yeah. You cannot, no, not at all. So it's one of these. What? So the AB ends, that is right, on flat high. And is not allowed to contain the opposite extreme. They are the type of AB, can be, it's only one. Only one. Okay. And then this becomes, the other one is then flat low and not allowed to have a maximum. in which case BC is blah blah blah, meaning that get in BC left is one of these. Two, and BC begins with a maximum or minimum. Ouch. Okay, yeah, in this case it's not unfound, is it? Thus, it's like a given. It begins with flat high, then obviously it begins with a maximum. So I don't really need a test for that at all. Well, that looks correct. Yeah, it's the same. Check, double check, triple check. And then this list becomes, so that is the other side, which means that we are talking about having a minimum now. Which means that we must use flat low. And no other check. Which then gives this list, which is the same as we already had. Yep. I wish you could use colors in my comment. In the comments, but okay. Case 2. The type of AB can be blah 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 blah, which means it ends on a maximum or a minimum. And then BC is downhill, uphill. Yeah. So the only restriction, it cannot be the only restriction. It is not the only restriction. It can also not have the opposite. So I must continue here with and is not allowed to contain the opposite extreme. Therefore, type of AB can be Okay, so it must end on maximum. And cannot is not allowed to contain the opposite extreme. So it is not allowed to contain a minimum. Hope that's two. My intuition says we get two of them. We get one. Well, of course. Yeah, not of course. I don't know. Let's trust the program. In which case, the left side of BC is also, it must be the same thing, so this is downhill or uphill. That is, the type begins with, that is left, is begin with that, and then we get one of these, that's a lot. Or that, and we get one of that. Is that really true? Yeah, I think it is, yeah. It's just that's the only restriction here. That case you always get I mean, if it starts with this, then you always get a maximum first. You can never get a minimum first. Seems the only thing, yeah. So get end left is downhill for the first batch. Holy, what the hell? It's definitely not true. Oh. Left is downhill. Left downhill. think it's the same list. Let me just copy it like that. Same list, I can paste it in here. Make this an OR. So we have the slash and we have that one. That one is missing. Oh man, that's the last one there. That one and that one. Okay. Even in the same order. Or the type of AB can be, it means that it must be flat high. That's not true anymore, right? That's exactly the same as this one. Yeah, this I think it's actually exactly the same. So if we make it flat here, and then it doesn't, that's kind of the same as that B is on top of it, on top of the minimum or maximum here. So if you make it flat here, then this B is so close to it that it is the derivative of 0. And then these two become equal. There's no difference. So I'm just going to replace all of that with this. Same thing should hold for case 3 and 4. Okay, let's do those first. Okay, case 3. That means that the B is now the local extreme. So now BA can no longer contain opposite extreme. Thus I can say the type of BA can have get and left is downhill or uphill, respectively. I'm gonna call this trivial, so let's just remove that. Okay, begin with that one. So left is downhill. And we're not allowed to contain a maximum. But sorry, a minimum, the opposite. Yeah, this is probably correct. Yeah, let's test it anyway. So it must be right. Right must be downhill and end on a maximum. If it ends on a maximum, it's automatically downhill. But okay. Let's add downhill and then ends on the maximum. Maximum, okay. Blip. Ends on unfound maximum. Yeah, that would be these. Yep. Or uphill and minimum. Or the type BA can have get end left is flat, high or low, trivial, and is not allowed to begin with the opposite. Left. And then flat low and the other. Extreme. Maximum. Oh, it looks confusing. Let's see. Oh, CB is the thing on the left, huh? So right is the same type. And therefore it is also ending on that same thing, on the maximum slash minimum, yeah, of course. So the only thing I really want to check that it ends on a maximum, on a flat maximum. Yeah, this is just these three, which I already have. And in this case I get well, the opposite. Flat low. That one, or that one. Okay. And then case 4. Begin with a maximum. Is that an unfound maximum? Yeah. It's not allowed to contain a minimum. Seriously? Yeah, I guess it corresponds with that. In which case, the right end of CB is uphill or downhill. That is the only restriction. Yep. Really? Right. Uphill. No, it's the same. Probably already did this, so no, this is right. I did left before, I think. Perfect. And this again should be the same as that. It is get and BA left is flat high or low. Get and BA left is flat high or low. In which case CB, what the hell? I'm gonna delete it anyway. Is, and then this thingy is missing again. But okay, so the get and right of CB is flat high low. Get and right is flat high or low. 2, and thus ends on maximum minimum. So that is the same. It should also be the same. Just copy this one. Poo poo. Okay, now we have a full list for everything. So this definitely should be correct now. So we don't have the opposite in the last extreme, which is the start one. So in case 1 and 2, A does not have the opposite, so that doesn't have any extreme whatsoever, actually. Let alone the opposite. And in this case, we don't have a minimum, we don't have a maximum, so that's correct. And here again, we don't have a minimum, we don't have a maximum. And here we don't have a minimum, and we don't have a maximum. And here again, no minimum, no maximum. Looks like a maximum a little bit, but it's not a real maximum. This is not a minimum, not a maximum, not a minimum, not a maximum. Not a minimum, not a maximum. Okay. I want to treat the first iteration slightly different. So because the very first time it is a local extreme. Well, in the case 1, 2, I think, not in case 3, 4. It kind of depends. Wait a minute, let me have a look. So if we go, well, it depends on the direction. So if we go to the left, and then in case 1, 2, we start at the local extreme cubic. And otherwise, in case 3, 4, we start at the local extreme. But that's not what I want to test, really. I mean, if it is the starting position, then yeah, I'm not really interested in that. So maybe I should do. So here node equals start. In that case, I want to decrement if I don't want to stop. I want to stop if we see the opposite extreme, but the starting position, if it is a local extreme, is not allowed to have an opposite extreme. Wait a minute. What? The basic, let me think about this. Advance until we find the cubic. With a local extreme, or run into another with, but it's a bit confusing, isn't it? I know what it means, but it's just twice local extreme. So I want to stop if this is true. Now, because of the end, that means that this must be true, this must be false. So if that is true, then this is false, and the whole thing is false, and we stop. Or when x, y has a local extreme between x and y, which is what is being tested here. So that comment is consistent with this test. However, the first time we have to take a little bit more caution. So I could start with the same thing. And then refine it, because this is then the first time that we checked it. If the first time it fails, it means I don't want to decrement node, and or even worse, I did not decrement node, then I don't want to test this, because then in that case I do need to refine. That is still the first case, then node is still equal to start. So it really is that only if we do the minus minus, then we want to possibly continue. So the whole thing must be between braces. And only if we do the decrement we can continue. Which then, well, I would say begs for a do while instead. So let's do the minus minus thing first, and then just use a while. Maybe like that. Well, maybe like that. No, we don't need this either. Beautiful. Don't you like unreadable compact code? Nonetheless, I still have to fix this. So what do we want the first time? The first time I do not want to stop if this is a local extreme, because node could be a local extreme if it is a star. So in this case, if we go to the left, in this case if we go to the left, in this case if we go to the right. Now what if I am not on A, in which case I do not want to stop if this is a local extreme, but I am on B, and B is marked as local extreme. Is that, do I then also not want to stop? Well, that is super unlikely, I would say, but it is possible that the cubic BC, which is definitely having a, let's say this is a minimum for easy talking about it. B is super close to the minimum, so B is a minimum, but C could be the maximum, and we want to find that. So B could be marked as a local extreme where this cubic contains a maximum that is used for the maximum close to C, which is then either on this side or that side or on top of C, somewhere here close. So now C plays the role of this B, but then for the maximum that is around here. That is possible. And in that case I have to stop as well, even though it could be that there is a minimum then first. Very confusing probably. But yeah. So I do want to stop if the very first one is marked with a star, but only if that is the opposite type of the one that I'm looking for. Same thing here, doesn't matter if it's left or right. This could have a maximum around C. And here also, no, that's nonsense. This arrow here. If we start here, then of course CB could be marked as the cubic used to find the extreme around C as well. Yeah, so it's just in all cases, I'm afraid. Looks like it. So the very first time you want to stop also if it is a local extreme. But only if that local extreme is of the opposite type. So not local extreme and node local extreme. And then I need to get the type of that. Okay, what does this return? Local extreme returns a local extreme reference. And then the type of that is stored in local extreme. So that would be get extreme type. Wait, there was a reference. And then the opposite of the current extreme. What about this? Node has extreme. Can it have the extreme that is just the current thing? So in this case, for example, we do not have an extreme because it's outside of it. Although it could be that B is flat, in that case it does have an extreme. And of course that extreme is then again the current one. In this case it is even contained in it, so then we definitely have that extreme. So also there we have to check the extreme type. Now in this case, yeah, we could have the flat one here. And here it's again contained. So for the starting one, it could have this minimum as in could be flat low, the type of BA, and here the type could be min or flat low or whatever BA can be. So case 4. So yeah, it can have an extreme, but that will then be the same type as the type of the next extreme type, which is this. Uh, 3, 4 cannot have an extreme. So it's not the case that it can be flat. Okay, 3 and 4. Why would it not be flat? Oh yeah, flat. Yeah. Yeah, it's the same thing basically. Basically. Yeah, up has extreme, node has extreme. I just want to pass extreme, of course, that I'm looking for then. So I don't want it to have the opposite extreme again. It's this one. So we can keep it like that, and then pass this argument to opposite extreme. I'm missing a node now. The cool thing about using the do while is that I can now move this difficult test outside this if. So I'm going to change this one into the same line as this one, but with a plus plus. And then this, that, delete that, and then delete that, and then move all of that outside of here. I don't really need to start anymore, I think, although maybe later. This is only true if the node is on equal start, for example. kind of, well, it's more complex than that actually. If we think about this again. Gonna negate this, I think. Or what is it called? So now we have, if it is not a local extreme, yay, who cares? But if it is a local extreme, well, that's okay, that's still okay, but then that type of that local extreme must not be equal to the opposite type. Yeah, that makes sense. And also, the cubic that we are on cannot have the opposite extreme. I think this is correct. Now about the assert. Yeah. If the node does not have this sort for, suddenly this looks like a weird word. Is it even correct? So it's sort. Oh. The node does not have the sort for local extreme. Then it must be a local extreme cubic that has its extreme outside of the cubic on the side of direction. Okay, we stopped one node too soon. Okay. So if this node has the either the node has the extreme of the opposite, it's the one that we were looking for. Or if it doesn't, then the node then we must have stopped because this node is a local extreme. And either we're going to the left and there is nothing on the left, or you're going to the left and then the next node, which is in the previous node, or we're going to the right and then the next node is the next node, does have that extreme. Looks also good. However, does these two asserts also hold for the very first node? So if we never incremented or decremented it. Let me make a copy of this. So we never decremented it, and node is still equal to whatever the arrow is. So in this case 1, it would still be A. And then we say node does not have the extreme next extreme type. which could fail if this is flat here. In the case 2 it definitely fails. Or has extreme order. So we're going to the left, and then the next extreme type would be left of. That's bullshit. It definitely does not have 2 extremes, so this is certainly false. So this test definitely does not hold for the first type. Neither here nor there. And in this case, kind of the same thing, huh? Just pretty symmetrical there. Yep. Think about if there's nothing I can test in this case. If node was not changed, then this was false. Yeah, we're just talking about 8 different cases. All the arrows. So 1 by 1 then, I guess. If we stop on this one. That means that node is not a local, let's go, not a local extreme. Well, it definitely is. Or the extreme type is unequal the opposite one. That's true. So if we did not decrement or increment it, then this must be false in that case. Which means that this must be true. Which means that it would have an opposite extreme, but which is not allowed for the start cubic. So case A1 should never have node equals start. So it should not be case 1 going to the left. And then this one. I'd rather look at this one first, actually. This is kind of the same thing. If we stop here, it should be impossible, shouldn't it? Yeah, it's not possible. And here as well. Cannot stop here. Can we? If we stop here, that would be because either it's a local extreme of the opposite side, which is not possible. It's already a local extreme of this this type, so can't be both. Nor is it allowed for a start thing to have two extremes. Well, now I think about it, this one could still have an extreme near A. So the question here is that really true? So we want to go for case 3, the type BA. BA. There's no extremes at all. Or one of those, which is the same extreme. So it cannot have the opposite extreme. So that's not allowed, yeah. Yeah, you can never stop like that. So we can start with an assert like that. Last extreme cubic is the one that is has a star. So if it is, it must either be changed or it can't be a star. Take a, it can't be last extreme cubic. That leaves 4 cases. So if node equals start and it is not a star, is then there anything that we can assert on? So in this case that would be then it is still B. If it is still B, that means that let's say this thing is a minimum again. We stop on B because we already see the maximum. That must be then that C is the maximum here. Which means that And I think it's the same test as this. So you would say it's unequal start, or this is false and this is true. However, that would then only be tested if this is false, which means that this is true, or then we don't test it. Yeah, so got to add the same test here. Storage on eagle. I'm trying to think of a way to combine these two, because now this long expression is the same as that one. It's a bit annoying. Can we not combine that somehow? As if ChatGPT knows that. I'm asking it anyway. Oops. I have two asserts. Assert A. What was it? Oh, I'd call it not A. Not A. Or B and C. And this is the opposite of that one, so this is then A, or, and then this is the same as that, so that's C. Hi, Abhimanyu, Mr. Ninja. That's a fuck you. I hate this so-called AI. So it uses C twice, and then it just answers the sentence. This single assertion assures that both conditions hold and that C appears only once. Yeah, it does not appear once. Is that true? Well, maybe it now completely blundered. So it says that if this is true, I forgot what the original was. That's not true, is it? Just ask a few humans. Let's ask the humans. I'm gonna go to Discord, help channel. I have. Is there a way to write this as a single assert such that C only occurs once, preferably also A and or B should appear once possible. Andrew, yeah, super accelerated, man, except it doesn't work yet. I had this brilliant idea, and the idea is still brilliant. I just can't get it implemented. So, chat, you can help me with my question. This is not a difficult question, is it? So, let me repeat what I said on Discord. So, can someone answer this question? Type it in the chat if you know the answer. I'm too lazy to think about it myself at the moment. Plus, I should eat dinner, I realize. It's almost 9 p.m. and I basically didn't eat anything today. Great way to lose weight. I'm still not hungry. I lost 2 kilograms in the last 2 or 3 weeks, I think. I think I'm now below 71 kilogram. Or was it 72? No, 71, yeah. I think I want to go to 68 kilogram. I'm not sure if I'll probably want to start eating nice stuff again before I reach 61 kilogram. I already did eat a piece of cake with whipped cream today. So we went out on a terrace and I got a cup of coffee. They didn't have tea. Yeah, the machine is broken. That heats up the water. So can't you boil someone? I mean, it was a restaurant. They have the complete kitchen. So just boil. Then I have to put water in a kettle and warm that up. I'm not gonna do that. What the fuck? But yeah, I was with 2 other people, so I didn't make a fuss about it and walked away. So I just ordered coffee and a piece of cake. So I did eat that. Yeah. Nobody's gonna help me, huh? Okay, I'll give it a go myself. Yes, should. Okay, either C is true, which makes this true, and either A is true, which makes this one still true. Well, this is bullshit. Wait a minute. If C is true, then this is true. But it's not enough for that one. So in this case, we must have not A is true or B is true. Let's see. Do I have it now? Of course I don't have it. I mean, now I demand that C is true, otherwise this fails. So if C is true, then this is true. And either this is true or that is true, then this is also good. Yeah. And now we still have the case where C is false. So this is the case where C is true. What the hell, dude? No, there you go. What? Or so now this is false. And this is false. Oh, that's not possible. If C is false, it fails. No, you gotta be kidding me. What am I doing wrong then? I don't believe this. If C is false, C must be true, because if C is false, then A must be true, therefore this just fails. One of them fails in that case. I guess this is the solution here. Can't be right, of course. That can't be right. But maybe it is. And here, of course, nobody helped me. Well, whatever. Okay. Yeah. Okay, it's actually correct. So not A and C. That's the first two. Yeah, okay. And this is really what I have here, because so we call this not A or B and C. And this is then A or, yeah, same thing, C. So I think indeed, C is always true. So we can combine these two. I'm wasting my time and yours, of course, but it was just annoying, you know, that I thought, well, come on, must be possible, and it was. So we're going to write this as It's just not true. This is not true. Third node has extreme, not node has the same extreme. Bullshit. It's just not true. I don't know what I did wrong, but this is not the answer. Nope. 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 Hello, Shaheen Bedilov. Probably completely pronouncing that wrong. It looked like an S. Okay, this is literally confusing the hell out of me. How can this... Am I this stupid? Why? Why? What? Dude. This makes sense, right? I mean, this is only tested if this is false, and if this is false, then no changed. Therefore, the comment starts with if no changed. Then it can't have the same extreme, aka it does not have the same extreme, unless it has both extremes, and that same extreme comes after, that is in the same direction that we are going, the opposite extreme, which is this totally. And then here we have why is my indentation suddenly 4 spaces? It's not there. So if node didn't change, then it can't be that can't have started on the local extreme cubic, because that does not contain the opposite extreme. Oh, wait a minute. Now I think I see it. This is the opposite of that one. I have to inverse the direction. So in this case, we did not move from the start. So you're still at the arrow. In that case, we can't be on the last extreme cubic, so we're not on a star. So we're either here or there or there or there. Let's take the one at the top. So for example, in this case, let's say that, let's take this case. In this case, it's possible that AB has the minimum and BC does not have a minimum. That means that it does not have the minimum. Yep, that would be okay. That it must have a maximum in that case. But I can test that later. I think I test that here. Yep. So It is actually perfectly fine in this case that it has the same extreme. Or it could be that this is included here. And it's not that it comes after the opposite. It comes before the opposite. It must even become before the opposite if we did not change. So in this case, if there is both a minimum and a maximum, then the minimum must come first, because this is the minimum and then the maximum is far away. Same case here. The minimum comes first and the maximum is far away. And in this case, the maximum comes first and then the minimum. But the direction toggled. Okay, so yeah. So in terms of direction, now we go to the other way. So then we're going that way. So the minimum comes first. So it's the opposite. It must be the opposite direction. Which simply means that we have a not as extreme order here. So what is then not possible here? What is not possible is that the minimum, it could have a minimum and then a maximum, or it could have no minimum and just the maximum. Can it have a maximum and then a minimum? I think even that is possible. No, it's not possible. Wait a minute. Yeah, it's well, yes, that is possible. There's no restrictions here. So if this thing is not aware of the minimum, then we can just get a maximum here and a minimum here or whatever. So anything is possible. Anything is possible, but we stopped, so it better has a maximum. That's the only restriction. It must have the opposite thing. But the test, if we have, so this is not true. It can have that, and if it doesn't, then it might not. It might or might not have two extremes, so we can't test anything. Just the whole thing is just bullshit. Yeah, this must be gone. That's the solution. And then, of course, we don't have and can't combine them. So these two then test what we can't have, and this one must test that we do have found the opposite. So either we found the opposite extreme, or we did not find the opposite extreme, and then we must have stopped on a local extreme. And the next one in the same direction, if it exists, has the opposite extreme. And I can even talk about the order in which they must appear, but I'm getting tired of this. So in this case I could say that if it does have the opposite extreme, and the node changed, then also the order must be correct. As in, I don't care that it has the opposite extreme unless the order is correct. But that order only counts when the node changed. So this must be between parentheses. And then I have to do and. The node did not change. Is that even possible? Or I think what I wanted to add here is exactly this. So that is already tested. This end is then not necessary. Well, the indentation should be like that. Yeah. Poo poo. Okay, finally we can run the test suite again. So previously this one crashed, now, and we still crash. Okay, so the picture here is 1 or 2 with B exactly on top of the maximum. And this is a maximum, as you can see. Label 1 is B and label A is 0. The starting point is, well, it depends on if we go left or right. So are we going left or right? Print a direction. We are going left, which means that the starting point must be A, and it is, because label start is 0. And then of course the next question is then what is the label of node at the moment? Still 0. Well, that's an interesting crash. I would say this must be equal then, because both are pointing to 0. So Boolean short circuit. This should never be tested, yet it's calling has extreme, which is this one. Bullshit. Print node equals start false. Really? How can they put line 1043. How is that not equal? Okay, I definitely want to step through this with GDB. This must be the first time we get here, but only after, of course, this program is running. So I want to put a breakpoint here after the last rerun, which is 25. That would be the start of handle LocalExtreme, which is early enough. Just rerun 25. And now we are at the top of handle LocalExtreme, which is, I think, this very function. Yep. So next. No, state is definitely unequal. Like I said, it was case 1, 2. Yeah, because well, one is close to it, and we're talking about there's only one cubic, so this must be A. So we do next, and then case 3-4 must be false. Yep. And then we begin with left. So now we are here, and then start should be put on on 0, yeah? Start should be put on 0. Going to the left, and you keep case 1 and 2 the same thing. So we do next. That is 0. Then we assign node to be start. Therefore, node is 0, and this time around, seriously, I insist, true. Good, good, good. So apparently we're going to decrement something that is not possible, and then we get undefined behavior. The thing cannot be decremented because we are at the beginning of the chain. That is, I guess, what is going wrong here. Okay, well, node is start is 0 is local extreme. So that's true. So we're going to test if not local extreme, but no, that's now false, or the local extreme type, that would be maximum, right? That is maximum. That's a big thing. Okay, line 1014. Well, you know this picture. So, okay, it says, I do the first time, if that maximum is unequal the opposite confusing. We should stop immediately. I think we should stop here immediately. So either it's not a local extreme, but it is. And then we want to continue if the extreme type is unequal to opposite type. We want to continue. Yeah, we do want to continue. So this is true. Maximum is unequal, well, the opposite. That is true, yeah. So the point is, we have here the local extreme that refers to the fact that this contains a cubic with an extreme that was used for this thing, and they're talking about a maximum here. and it is unequal the thing that we're looking for, namely a minimum. Therefore, we did not find a minimum. Found the local extreme, but it's just ourselves. Therefore, we do not want to stop. We want to continue looking for a minimum, going to the left. But it's more complex. Also, it cannot already contain an extreme of the opposite type. Well, it doesn't. But it could be something like this thing could be having also a minimum. But it doesn't. So this is also true. Yes, and therefore we do continue. So I do next. And we continue. Yep. Which is a good thing, but we can't decrement. We do go to the left, but now it's going to decrement it while we are at the beginning of the chain, which is not allowed. Oh. Yep, so this must be direction is left and notice unequal chain begin. And then also here we must have a check for that. We have to stop when we reach the beginning of the chain. In fact, same thing holds for this one. I have to stop when we reach end. Even though it can't already be end. I just dereference it and everything. So we can start with an increment, but then I have to, even before we do this, I have to check if it is end. Yeah, so let's change this code then. So this must be if it is left, but I also can't do an else then. So it's again like this. If node is unequal chain begin, then we can do this. Then we can decrement it, and then we can still dereference it. Doesn't really matter, I guess. I could test it even. I don't have to dereference the beginning because we want to stop anyway. And suppose this is true, then we still can't continue if it is equal to chain begin. So you can test here while it is not chain begin. And the rest, we can keep decrementing it. Yeah. I hate having these tests twice, kind of. So maybe I just have to use it in a break or something. So let's go back to what we had, and then I'm going to make this look like that. And then I do here if node equals chain begin break. Oops. Open break force. On the other hand, this is never the case the first time we entered, so it's kind of silly to do it here, isn't it? Yeah, so you can just first increment it and then check it, which means I have to check it here. So there must be node must be unequal chain end. Okay, so what does it mean if the node equals chain begin? Did we fail then, or not necessarily, right? In this case we failed, but here it could be that after decrement node becomes chain begin, and then we just exit because of this, in which case we did not fail. Then what if it is immediately equal to chain begin, like the very first time already? And then I can't decrement it, but I want to. Why do I want to always decrement it? Because this succeeded, which means that it's not a local extreme. And it does not have the opposite type. Yeah, so this is a failure. And I can detect a failure, I think, by, let's say, well, because we had a failure here, if it became chain end. Yeah, so this is just, we failed to find an opposite extreme. Okay, well, that was duplicated. Let's delete it again. Now, if node is chain end, then this will fail because start is not chain end. I mean, it is unequal, so the assert won't fail. And in this case, we have a problem. So this should only be done when this should only be done when node is not equal to chain end. Node is unequal chain end. Sorry, the opposite. Chain equals chain end. And here again. Okay, this gets tiresome, doesn't it? I just don't want to do any assert. Rather check this one. And still it fits on the monitor. Okay. Yeah, now I have my if diff around it. I might as well, no, not if diff, but if and if. Then might as well do that for the node as well, kind of more readable and stuff. This test only would do for if node did not change, aka node equals start. And then this one is for when node is unequal start. So if node equals start, we do this test. But then again, you can't dereference node end, so well, we don't even want to assign this anyway. If I do this, however, it could become node end again, so that's double nasty. Well, that's the test at the end for this direction. So we did not fail badly, and node is a local extreme. Then it really should be local extreme that we all after could add an assert. Probably already handled by the asserts above, but hey, who knows? Yeah, it's this one. Or not, because I even changed node afterwards. But that was already checked here, I think. Oh, it's so difficult. I think this whole check is the same as these checks. probably was already tested. Yeah, so luckily has extreme it has the opposite extreme. But wait a minute, this is only applied on previous or next. Huh? Oh yeah, wait a minute. Here has local extreme. So it already has the local extreme, in which case has the opposite extreme. Sorry. No, wait a minute. That's not what I wanted to test at all. No. Yeah, I need a new assert here. Anyway, okay, new assert here. It is a local extreme, and the so we get local extreme dot extreme type or something. What was it? Get extreme type. You must have definitely found an opposite extreme. Otherwise, the whole assignment is a bit, no, don't do this. Well, I mean, let's crash the whole thing. This should never happen. Yes, and then here we still have the possibility that now node equals chain end already. So even have to test it here. Like that, I'm afraid. And then we test it there again, because it's possible that here it is not equal to chain end. And it's also not a local extreme, but we were going to the right, and therefore we increase it. And that then makes it a chain end again. So we want to test if then we have a local extreme or not. Compile, okay. On this again, yes. And we crash, we still crash. Let me close my curtains. Be right back. Yeah. Can't go to bed until it doesn't crash anymore at that point. It's a stubborn one. You gotta be kidding, right? That's kind of the same problem as before, and I just dealt with it, I thought. Okay, what was with this? We did want to continue. So we should go to line 1017. Yes. Direction is left. And now we should not decrement it. What the f... Okay. Maybe I should be sleeping or something. Oh no, it's not. I thought it was going to sorry, I thought it was going to decrement. This is the break thing. Okay, great, yes. Node is set to chain end. Break. Node is unequal chain end. No, it's equal to chain end. So what are we going to do? We're going to not go to 1043. If node is unequal chain end, nope, it's equal to chain end. So we're not going to 1071. If node unequal chain, sorry, no, we're not going to 1040, sorry, 1083. And now we go to the next direction. Hey, we're further than before. Direction is now equal to right. Okay. Then what is start now? We go to the right. We go to the right. The situation was one of these. We go to the right. So now it should be put on B, which is level 1. Did we already pass that point? No. So next. Print start label should be 1. Yes. Next. Yeah, I'm not gonna print the label of node. Node is equal to start. 1014. Is doing the following thing. The first time, well, node is start, that's not the case. We only want to stop if node is a local extreme that is of the opposite type. Well, it isn't. So we don't want to stop. We might want to continue. We are looking for a minimum, not this maximum. We want to continue to in that direction, looking for a minimum. But there's no samples, but that's the intention here. So we should definitely get here. Oh, what just happened? Oh, I'm trying to get the type of a cubic. Well, the thing doesn't have a cubic. Okay, yeah, testing on chain end is not the correct thing. I have to test on this. That's the better test. Ugh. Exactly where am I doing that? As minimum. Yeah, as minimum. I can't check. I can't check extremes. Can't call has extreme on a node that has no type set. Line 1014. Or not. Snoring swap file. Scary stuff. Still 1014 looks weird. Wanted to go here. 1014. And what? Oh, never mind. 1024. Yeah, okay. Hey, Clement. So here I'm always testing if the node has an extreme of the opposite type, because it's an and a Boolean and there. But I can't do that if node does not have a cubic defined. So might as well begin with that. I could test this, but then maybe I'm going to try. Well, then this is also not true. Well, wait a minute. Is local? Wait a minute. Then is LocalExtreme is definitely not true. So if it does not have a cubic, then this is going to return false. So this is true. So I'm not doing the OR. But then we come here, and yeah, that crashes. So we might as well begin with the demand that the thing has a cubic defined. Oh, how do I test that? Type. And I think that SampleNode has a type. Constant quotient exponential function log power product sign is sum symbol SampleNode. Cubic to next sample type. Is there any other thing that we can use for that? I don't think so. Could have looked at it more often. Maybe I should add it. No, just testing type, I'm afraid. I could add something like a hash cubic or something, but yeah, I didn't, and then I didn't do it again, and then I thought, well, I'm testing type, a compared type with unknown all over the place, so let's not add a new accessor now. And now I'm stuck with that. If the type of the node equals unknown, then we don't have a cubic. Then this is false, and there we do not continue. However, the node is not equal to chain end. But like I said, that test isn't really the correct test. The same thing happens here. I'm testing on chain end, which is bullshit because I already crashed one before end. Can't call these things. So instead of testing for end, I have to test for this everywhere. Meaning that chain end Boomer can't do that either then. I wanted to set it to the one before and then maybe. Clement, what? A node is an iterator that points to a sample node, which is two things at the same time. Namely, a sample, it's derived from sample, my sample node, which contains the function point, so the x and y coordinate, as well as, if this is not unknown, the type of the cubic between that sample and the next one in the chain. So for the next larger x coordinate. And then instead of x coordinate, I call that a w coordinate, by the way. So being unequal and is in this case equivalent with still having a cubic, which means that the type is unequal cubic next sample type unknown. And that then in turn should guarantee that we never reach end. Although now I'm incrementing it. No, I'm not. So this is unequal unknown, which means that the cubic is defined, which means that the cubic to the next point is defined. So there is a point after node. So even after incrementing, if after incrementing we go to the point on of that on the right of this cubic, which then exists, of course. Otherwise, it wouldn't be a cubic. So after, if this is true, then an increment will not make it end, so we can still dereference it. Yeah, it's just a better test here. I really should make a method for it, I think. I don't understand your question, Clement. I just told you. A node is a standard list iterator with sample nodes, and a sample node is derived from a sample, and a sample is a point in my function. So xy coordinate, including the derivative of that point. But it also contains the cubic to the next point, if that next point exists. And then you come with, I'm using too much drugs questions like, it's an if in a scope. I mean, dude. Well, it's a variable name, so I can name it a node if I want to. I could also call it your sister. I would have no idea why you think that a node by name is a state. Usually a node is used for something like an element of a list, which is what it is. My name is Carlo without an S. Guess we reached it. Yay! No crash. I can finally go to bed. Now I can finally eat dinner, I mean. 10:30 p.m. Okay, shall we run through this again, just to see if that now it works? So, next. So what now happens is we get. We try the left side. Why did I stop again? Oh yeah, because of this. So then we do the break, and then we go to the next node, which is does not have a cubic. So this is this is false all the time. It is unknown. So then we don't do anything. Oh, wait a minute, that's not true. Now we get the other direction. Do we still have my node? Probably not. We do. Yeah, well, node 1 did not have, okay, what the hell. Oh, that, never mind. Another direction, question mark. No, we're already on, no, we're going to the left. Going to the left, why is node 1? Does that make sense? No, it does not make sense whatsoever at all. False. Left. Zero. This should be left max. Yep. Yep, so start is 0, node was set to start, and this is the left part of a maximum. Hence left max. Put it here so you can look at it. So this is true because it is left max and not unknown. And not local extreme, but it is. It is a local extreme. This is the cubic that was used to find this extreme. So this is false. But this is true. Because the extreme type is a maximum and the opposite is a minimum. So it's unequal, therefore it is true. But this must then also be true. Does not have an extreme of the opposite. Also true. So we should get at 1018. Yep. Direction is left. And then, but node is equal to chain begin. Because we are at the beginning. So now we break out of it. We set node previous chain end. Hopefully that works. Oh, I really didn't understand how it was ending up at 1. And you go, we're going to the left. But that we set it to 1, which is the end of the chain, in order to signify that we failed to find the minimum. Okay, that's the reason. For some reason it does that line twice. Yeah. Okay, so now node label is 1, because which just means that we failed, because that means that there is no cubic on the right of that one. So we break out of it, and then we failed. So yeah, is node unequal unknown? No, this is now unknown because it's at the end of the chain. So it is unknown, but we don't do that, we don't do that, we don't do anything, we just failed. Now we go to the next direction. So now direction is right, which means that start must be set to 1. Yes. And The node is set to 1. That means that node doesn't we already failed. There's no cubic here. I mean, notice now we start here and we want to go to the right, investigating cubics, but there's no cubic at all on the right of 1. So now we don't do anything and we just are done. No other direction. And hence success. Okay, so up. Let's edit this. Remove this line. Try to run the whole test suite again without drawing anything. Cross fingers, crash. Cross my fingers too late. Just already crashed before I had my fingers crossed. But hey, restart went to 84. So we passed something. Which test is this? And LocalExtreme, operator. There we are. And I think this is still where we were before as well. I guess if we have an I0, yep. I1. What are the other variables that we have? No extremes. Oops. That's still 0, and maximum last also still 0. So it's 2 and 3 is the one that goes wrong. Let's turn on drawing for that. Where was my drawing thing? I commented it out here. So if I0 equals 2 and I1 equals 3, turn on the drawing. I think I can just restart it for you. Yes. Rereading it. So that would be this case. That is 0, and then we immediately crash. Curious. I am curious what it is this time. Assert that LocalExtreme get extreme type must be equal to, oh, we found an extreme, but it is not the correct one. Oh, we found ourselves again. So next extreme type is the current one, which is maximum, and apparently we found something that which is impossible. So with the fact that we found anything at all. What? That's an undefined thingy. Maybe it returned to 0. Let's see, is LocalExtreme. It is a LocalExtreme and it returns nonsense. Whoa, what the... Yeah, well, that's strange. And that doesn't look like it's on the heap at all. Okay, I put my bet on that node is bullshit. Think. So we cannot print the label of node either. We can print the label of node. Well, that 0 is begin, so something went wrong. Maybe it's equal to end. Yeah. So node has reached the chain end anyway. I thought that wouldn't happen. Hey Felix, yeah, 7, really? Unbelievable. Okay, so never dereference an iterator that is pointing at the end of your container. And I thought that we would never reach the end because the end is past 1. And we would already stop on 1 because 1 is not defining a cubic to the right. There is no cubic on the right. I mean, every cubic is defined by 2 nodes, 2 samples, and we have only 2 samples, so the only cubic that exists is the one between 0 and 1. Well, a piece anyway. The whole cubic is, well, this is the cubic, but it's defined by 0 and 1. Okay, so yeah, nothing defined on the right of 1. How did it become end? That is the question. Well, handle LocalExtreme -3. That is 0.0. We jumped back. It's just run the program again from the top, I guess. I mean, it's almost immediately after the restart, almost immediately a crash. Shouldn't be that difficult to reproduce it. So you see here's a jump point. Green arrow points to the jump point. So I think what happened is we added 0, we added 1, then we fit the cubic, and then we jump to the extreme of that cubic, which is again 0.0. Yeah, so now we are contemplating adding 0.2 here. Discover that this new point is super close to one that already existed, namely 0, and therefore we abort, saying, "Hey, we found the." That's not true, actually. I think it should be doing that twice. Maybe we jump back and then said it's super close to 0, so I'm going to reuse 0. Therefore, we didn't add 2. And then reusing 0, we did reuse also the cubic that we already had, and then we jumped again to the maximum, and then we jumped twice to exactly the same place, which means there's no improvement, which means that we already reached the local extreme, which is the maximum. And therefore we call handle local extreme. And then -3, which is here, 0, is the local extreme. State must still be find extreme. So no extra sample there. That's -3. The last extreme cubic is the cubic that was used. Well, there was only 1 cubic, so that should be 0. I name a cubic but a sample on the left. Yeah, so the cubic between 0 and 1 is called 0, And I also use an iterator that points to that. So even though I call this a cubic, you see I talk for much more. Now we have 7 viewers, chasing everyone away. Four viewers. Okay, I'll stop talking. No, well. Yeah, no, sorry, Felix. I always just concentrate on what I'm doing here. If you want to talk about something else, join Discord and give the details there with their links and everything. And then when I have time, I might look at it. Discord. Every stream has the Discord link in the description. Yeah. Oh, you want to know what that sound was? I can show you that. I bought this. It's 4 liters of water. So now it's just standing on my desk, as you can see. This is the left monitor. I have 3 monitors. This one is on the left. Discord, Telegram, and the water. What was it, dispenser or something like that? Yeah. Well. And the phone number that you saw is of a company called Rodor that makes headsets. So there's absolutely no reason to call them. In Germany, I think. Aviation headsets. No, I don't own a plane. Aviation headsets also work when you just sit behind your computer. Oh, you didn't know? I'm streaming from my private jet. No, I'm just kidding. Besides, I would have been the pilot then. Should have been a pilot before having an aviation headset. Let me concentrate. Definitely false. No, wait. This is case 3.4. This is case 3.4. This is true. I'll have an actual look. Yeah, so 0.0 is close to the maximum. So 0.0 is B. Close to the maximum. And the other point, which is represented by A, is on the right. So it's 3 or 4, but there's no difference here because actually 0.0 is exactly in the maximum. So this distance is not there. A B is on top of it, so there's no difference here between 3 and 4. So this should be 2. And then we begin as usual, of course, with left, going to the left. There's no going to the left. There's nothing on the left. Start should be set to the arrow going to the left. Well, that's interesting. C doesn't exist. Maybe that's what's going wrong. Yeah. Okay, that's it. Can't go to the left. Not checking that. So I'm doing a standard previous here on the begin of the chain. Whoops. So annoying. So that was the 4. How to solve that? The other way is also problematic, I suppose. If the last extreme Q points to 1, I also don't want to increment it. Seems like really impossible to write some fast code here. Damn it. Yeah, if case 3 is unequal, direction equals right and direction equals left, then case 3, 4 is false, right? No, wait a minute. If this is left and this is false and this is unequal, so case 3 is true, obviously. Het werkt. Yeah, I have so many asserts. I guess I don't really have to look at it again. It's just before it crashes. No, it doesn't. It works. What is it with the arrows? It wants to go to the left here, or what? Yeah, probably. Guess, yeah, that's reasonable. It wants to go to minus infinity. Can't blame the whole thing. Looking for a minimum. Going to try the full thing again. See if now we go further than 84. 101. Well, eventually I can go to bed, probably. Eat something even. Yeah. What is it this time? Last extreme cubic has extreme crashes. The LocalExtreme cubic cannot contain an extreme of the opposite type. Well, that doesn't even exist. SampleNode has only one LocalExtreme pointer. If this fails, then please fix by inserting an extra set. This is no way the case. I don't believe it. Up. Still line 492. Come on guys, be nice to each other. I don't like not nice people. take it from me, good life lesson. If you have nothing nice to say, then don't say anything. It's definitely in real life a good advice, and why not use that in the internet as well. I think you're being nasty, you know. Well, wait, Felix, no. I was talking about Clement. I didn't read everything, but I saw Clement say, shut up. You dream, you don't know mathematics, you are poor. That are all kinds of things that you just better don't say. You can think it, but you don't say it. It's not smart. This is still the same test, right? So I can still print I0 and I1, and I've got the other ones, of course. Maximum first, wasn't it? Nope, not. 492. Got that. Maximum last. I was close. Still 0. And then we have the other one. Yes, extreme. No. No extremes. Still 0. Progress is slow. Okay, 2.6. Very slow. You go straight from 0 to 1. That means that this cubic now contains both extremes. I'm afraid this is the case where we have to add an extra sample in between to break it. You can't use this one. I'm not even certain if it looks for the maximum or the minimum here. Probably kind of random. But I disallowed it because I thought otherwise, yeah, I don't know. I can't get it to work. It was difficult enough. So I disallow using a cubic that has both extremes, the maximum and the minimum, to define one of them. So probably this one is defining the maximum, and then since this cubic here has a minimum as well, we assert that. That's my guess here. Yep. Going to do the rerun anyway. See if we can go a little bit faster. Set LocalExtreme. What the hell? That was fast. Oh, I mean, oh yeah, with a little. Okay. Never mind, and should not have done run, or should I? We just restarted the whole thing. Okay, crash first, rerun. Yep, this is it. So the problem is we want to use this cubic labeled 0 to define that minimum. I talk about far away. Well, it fits it exactly because the underlying curve is a cubic, so it doesn't really matter where you pick your points. It's an exact fit. So why not? But then we will get a problem if we want to define this maximum as well using the same curve. So I have to add a point in the middle here. So what happens is we add 0, then we add 1, then we fit this curve, then we decide that we want to find the minimum, then we jump to the minimum, then we find that the new point, that would be point 2, after jumping to this, the minimum between 0 and 1, is exactly on top of 1. Therefore, there is no improvement. Therefore, we found the minimum. Therefore, we want to mark the cubic that was used, which is the cubic between 0 and 1, aka 0. We want to mark 0 as the local extreme cubic, as in the cubic that was used to mark the cubic that has its local extreme, its local minimum at the minimum that we found, this one. And then when doing that, we check that the cubic itself does not also have a maximum, but it does, because yeah, it begins literally in the maximum. Kind of surprised. Oh, wait a minute. These points are artificially set. We also had a case where 0 was here. But if we put 0 here and 1 there, then we're going for the maximum, I think. And then the cubic is still between 0 and 1. So then we want to mark 0 as the cubic that has the maximum. What about it? Still has the minimum as well. I would think that it should have gone wrong before. Let me okay, I understand this, but let's see what happens if I change yeah, if we put this one back. Do you know 0 is before it and then 1 is put here, so why is it not failing in this case? Oh, because I stop before I detect the local minimum. The only thing is test here is 2 points. So now we jump here and then we just stop. I mean, otherwise I would have jumped again, and then we found that this is a maximum, and then we want to mark 0, and well, we never get there. We never get there. Now I hit space, it just fails on the next one. So that would have failed if I just let it run longer. Okay, so what to do? I think I'll go to bed. 11 o'clock. I have to shift my day because beginning October I have to go to the hospital for 3 days, and then they will wake me up at 7:30 in the morning. I haven't been awake in 20 years. Though now I'm desperately trying to shift my day, so I get up at 8 or something. Yesterday I got up at 12 noon. Yeah. So we're getting there. Okay. Chess time. I'm not going to bed until I lose. Let's think. I'm out of theory, if there's even was theory. I once got a chess lesson from a chess master about his opening, and I think he said I had to play this pawn. I don't know anymore. That was probably because normally I would have played this knight, but if you want to have any chance in this opening, apparently you first have to do something else. It was here, so why not this pawn? Now I can put the knight behind it. Maybe just stop this pawn from advancing before castling. Yeah. Yeah, maybe I should have gone back here. This point becomes now deadly weakened. Let's cast long, then I can just push my pawn more easy. I castle long too. I use all my pieces. Look, Mom, I use all my pieces. Yeah, what shall I do? Okay, let's go there. That is the stupidest move I've seen in a long time. Going backwards. But how can we punish this? I want to punish it. Talk about punishing. Today I played. I went out. No, what was it? I have a play on the club, not chess, something else. And then the game first with a super high score. Like really high. It wasn't the record of the club, but it's getting there. I can't even explain what it was. Let's see, what shall I do? Well, I was going to push this pawn, so let's just push it. Then answer me this. There, he's gonna push, huh? He's gonna push. He pushes, and then I have to move my knight. Knight could go there. That's actually not a bad square. Then he's gonna take here, maybe, but okay, that's still a symmetrical pawn structure. The obvious choice. Okay, let's push myself. And now I have a shitty knight. Well, my knight wants to go there or something, or here maybe. 3 moves. It's too far, too much. I think I'm going to push this pawn, the why not pawn. This is kind of a nasty cut off though. Maybe do this first. Push this pawn. Nah. Oh, actually. No, this is attacked. Difficult. Okay, I'll just do this. I'm running out of time. What am I listening at? Still anima drop. Anima drop is good. That guy deserves more listeners. N-A-N, I'll type it in the chat. So really, anima drop. He's on Spotify as well. Just search the guy. It's very good for programming as well, because no singing, only instrumental, and very good. Okay, now I can go here. Okay. Oh, it takes like that. That sucks. Sucks. I can go here though. I'm scared of this rook doubling of my opponent. So double attack on my bishop. I can not play my knight back because I just takes it. And then I lose the bishop. And that's still happening, it seems. Oh boy, oh boy, oh boy. Okay, do something with my knight, maybe here, maybe there. And then I attack the rook, and then the rook takes here, so I cannot go there, so I have to go there, and then he takes that one. Which means that I have to go here, defending the pawn. Yep, there we have it. Problems all over. Serious, serious problems. That bishop is not moving anytime soon. I'm saving the day. My bishop can move again. I'm going to kick the knight. Oh, that's a nasty move. Very nasty. Sure. Strong, strong, strong move. I don't have any defense here either. And I'm running out of time so bad it's not normal. Let's just give away a pawn because, yeah. What are you gonna do? Oh, that's worse. That's way worse. Oh, I should have seen that, of course. And I might as well give up now. I might as well give up. 3 points down. My bishop is falling. Almost. 3 points. Okay, I'll have to wait on time. How am I going to do that? To win on time or not to win on time? That is the question. I should just give up, I think. I should just give up. It's nothing. Nothing, is it? Literally. Not a chance in hell. And now he's gonna walk with these pawns? Oh, he's not. I can't, oh boy. Attack it and then give it away. Yes, he gives it away. That's very nice. Maybe I still have a chance now. So now we need to capture this one and then promote. Check goes here. Check. He can't defend it. definitely a problem there for Mr. Black. Well, can go here, but then he wins a tempo. I have to go somewhere. Have a give check, why not? Looks like a good decision. Okay, now we promote. I'm so going to win this. Wait a minute. Give another check. I have to stop that pawn. I'll let it come here. That's too late, is it? I can't go there anymore. Nope. I'll have to sacrifice it right away. Okay, thank you. Too late. Definitely too late. He resigned. Yeah, we can meander like this. Take everything. Well, that was amazing. As in, I was totally lost, and I said I'm not going to bed until I lose. So next game. Yeah, this one of course. What am I doing? Stupid move. A very, very stupid move. He should have taken with the bishop. I'm not sure if this is correct. So I take here and then takes my queen, of course. Take here. Oh, we take the bishop. That's not good. I move the queen here. Move the queen here. You can't, that's kind of pinned. I mean, he must go there to attack the queen again. And then, if I take the queen, that's still not good. Well, then I defend it again. I win a piece, like. I go here, it goes there, I take the queen, he takes my queen, I take back, and I defend my piece. Wins a piece. But he's +4. Oh, yeah. I have to, but, okay, well, I wasn't so bad. It was bad anyway. I think this is still my best option. But yeah, then I'm 1 point down, and he's going to win this one as well. It's 2 points, too much. Duh. Such a bad. This is so bad. What else can we do? What else can we do? I can't move it away. I can put something in between though. No, he just takes my queen. Just, if he goes here, I have to take his queen. The guy is thinking as if he wants to keep his piece. What? Okay, well, I'm piece down. I really have to take the piece. I can't attack the queen, really. I have to take it. So now he's still +1. Better than +2, though. So... my development isn't that bad. Maybe I have compensation for that lost pawn. Yeah, let's develop my rooks. What is black going to do? He's going to castle and then play one of the pawns. If he plays that, the pawn is just lost. So let's develop this rook first. Now he's castling, so now I can... where does my other rook go to? I think here. It's a bit vague. I mean, there's two bloody bishops in front of it. Maybe I should have started with this bishop. I should have started with this bishop, definitely. Keep the initiative. Now we can develop this bishop here. He doesn't. Okay, he pushes it. 1, 2, 3. 1, 2, 3. So I take, he takes, I take, he takes, I take, he takes, check. And then I win this pawn. No, because it's check. That kind of sucks. So then I'll have to play this. What kind of move is that? I'm still having two bishops in front of my rook. Really? So otherwise I could take here and then take the bishop. One of them can be played maybe with it some kind of... no, I cannot. He just puts that one. This one is nice here. And the other one, the other one is the best. I think still here though. No, bishop here. There's nothing here. Probably better looking that way. Maybe here, threatening to take it. Oh, yeah. Resolve the double pawn. Now chasing this undefended bishop away, which is... yeah. Oh, now I can play this. Let's first play something else. But I can do this. Well, he goes there. And then I attack the pawn, he takes. And then that one comes there. Does it help me a lot? Not at all. Let's just go here. Oh my god, two bishops so in the way. I could have put my rook here now, which is also beautiful. Yeah, who cares? I hadn't even seen it, but... one more move with this bishop and I really get loose. This is not a super bad position because stops the rook from coming here. Also allows him to develop this bishop though. If you develop the bishop now, I just take this pawn, so you can't do that. Can't. I have to play this, I think. Wow, what is this guy doing? That makes no sense whatsoever. I'm gonna go here. Then I'm totally threatening to come there. Yeah, it's winning, eh? It's like winning this. It's totally just winning. Okay, the bishop comes here, of course. No, it can't. Can't. I stop even that. He has nothing. Not well. The bishop can go here. Yeah. Okay. Shit. Could have been so nice. It could have been so nice. Well, this one doesn't do anything anymore. There. It's a bit weak pawn, huh? A very weak pawn. Now I have to play this just to defend the bloody pawn. Wow. Keeps attacking it. No more weak pawn. Oh, I'm pretty happy with that. So I go back. Is that good? No, why not? Oh. Okay. I missed that one. I will admit it. Oh, how shitty was that? That was a full rook. I should instantly give up. Oh, I hate this. I don't see any more what to do now. It's finished. There's nothing left to do. He is +6. He's planning to play that. I have nothing. I have completely nothing. Nothing. Nothing whatsoever. Panic. Horrible. Yeah, no, nothing. Ah. No, yeah, there was no move left, I guess. I was hoping for stalemate, but then I had to lose 2 pawns first. Yeah, you can go to bed. How to go to bed depressed. Keep playing until you lose. Hey! That's actually correct. Yeah, another one. It's so time for me to go to bed. Good night.